All right, so in this video, we're going to look at how we can work with string columns in Pandas. So I'm just going to run these two cells. So first, importing Pandas as PD, reading in our data. We're using that store sales forecasting data. Remember, we had to do that encoding switch. And then in a previous video, I showed you this little piece of code right here that I kind of like to use something like this to kind of standardize my column names. So when we run that, if we look at the head of our data, let's just get the first two rows, right? We can see that we have a data frame that looks like this. All right. And one thing that I did want to, just kind of show you is that, a lot of times when you read in data, there's going to be some cleaning. That's actually a big piece of it. When you're doing analytics work, there's always that quote of, roughly 90% of your time is on data cleaning. I think it's more than that. I feel like the majority of my time working with data is doing some type of data cleaning. It even might be that, okay, well, I've run some computations and I can see that, I can improve the efficiency if maybe I have columns formatted a little bit differently. It definitely 90%, probably more. And a lot of that can be, especially if you're working with string data, working with cleaning up those strings, right? So let's just kind of look at some methods, and these are going to be a little bit contrived, and that's going to be okay. But to show you what we have access to in Pandas for working with strings. All right, so for now, let's just say that we wanted to take this customer name. So let's assume that we're thinking that it's in a last name and a first name format. So a first name, last name. So Claire Goot, I guess. So Claire being the first name and then Goot being the last name. All right, so let's work with this column right here. So let's grab that customer name column. All right, so I'm getting that back as a series, right? And of course, we might have some special cases. Maybe somewhere in here they have put a middle name, right? But if we were to do a dir on this, so if I were to run dir on that series this return, you can see we have a tremendous amount of things that we can do with it, right? A lot of these things are for numeric computations because, again, really underneath the hood, this is being stored as a NumPy array. And I know I've said that a lot, but this let me show you that really explicitly. So if you grab a series, so in this case, I'm grabbing this customer name as a series, right? So in index label 0, the value is Claire Goot, it's Sean O'Donnell in index label 2, and so forth. There is a values attribute that you can call, and it's going to return those values, and notice what it returns it as. So if I check the type of that, that's just a NumPy array. All right, so these things aren't just NumPy arrays, all right? And so that's, again, if we look at dir, why we're getting all of those numerical methods from, because if we were to go back to NumPy and see the things that are available in NumPy array, well, we can do a standard deviation, right? We could take a mean, which is right there. And there's a lot of extras that are defined in Pandas, but a lot of these are inherited directly from the fact that we're dealing with NumPy arrays. All right, but one that we're going to be interested in this video, I know I'm scrolling a lot and hurting eyes. So if I do that dir, I can see that I have this str method or attribute. It's actually essentially pointing into a class, or essentially a subsection of methods that are available. So if I were to go up and then do .str, all right, first off, let me take that out of the dir call. All right, it's saying, well, hey, these are string accessors. So these are my string methods. So if you have a column that's a string, you have access to string methods through that. Let's see if tab completion works. Oh, it did. That's great. And then look at what we have. So some of these are very familiar. So we've probably seen casefold before. We didn't directly use it in a video. But things like, let's see. So lower, right? So strip, we've seen strip before. So those are Python string methods. So just normal methods that are built in all strings, plus some additional ones that are Pandas specific. All right, but this gives us access to them. right? So if I've got my customers here and I want to make all the names lowercase, I could do a .str, so access the string methods, and then I could do a .lower, and now there's the names lowercase, right? If I wanted to, for some reason, if I wanted to replace the spaces with those underscores, I could do a str.replace, and I want to replace single spaces with underscores. Whoops, there we go. All right, so we can do these operations on columns. So this is kind of the first introduction that we're having right now to a very important concept in Pandas called vectorized operations. And this is one thing that makes Pandas really nice. And a lot of people that are coming from other languages, if you got this data frame, the first thing, if we wanted to make all of the names lowercase, the first thing that pops to mind is, well, I need to write a for loop. Right, so maybe I need to do a for loop and then use that .loc to access the values in that column or in a particular row and column, and then replace all of them. Right, so let's just look at what that would look like. So that's a great little detour. So let's say that I've got Pandas. Here's my data, and what if for some reason I want to go in and make all of these values lowercase in customer name? All right. Well, what we could do is we could say, well, gosh, we could say, well, for index label in my index, so data.index, right? So that's just going to print out my index labels. That's going to iterate through them, I should say. So let's do index label. It's going to print a bunch of stuff to the screen. Let's see. Oh, index is not callable, right? But there's how I can get my index values, right? All of them. All right. So, well, okay. So we can go back and get all of those. And maybe what we want to do is, again, we want to get this customer name, and then we want to make that a lowercase. So I could say, well, customer name is this. Customer name is going to be equal to, well, I need to go data.loc for whatever my index label is. And then what column is the customer name in? Well, it's this. All right. And then I'll say lowercase customer name equals that dot lower, because that's a string that it's going to be returning. Hopefully, we'll find out. All right. And then what we'll do is we'll say now we'll reassign it. All right. We'll do something like this. Is equal to my lowercase customer name. Right. So that'll run. Notice it took a little while, right? Let's actually time that. So let's do a time it. That's taking 234 milliseconds. Let's just look at data after that. So let me run this in a separate cell. And then we'll look at data. All right, well, that achieves the goal, right? We wanted to lowercase those names. Let's look at the other approach that we just saw, right? So this is, again, when we look at this gets the job done. It's a for loop. We're having to use the loc thing. That's correct. But it's a lot of syntax, right? And we're passing around this label. Instead, what we can do, right, is just take customer name and then use the string methods, and we'll just do a lower. All right, so that's essentially getting to the same thing. Let's just clear everything out of memory real quick just to show you. I'm just going to run this cell, and instead of doing our for loop, just to show you that, well, that's doing it, and I can overwrite the values in that column by just reassigning to that column. All right, so there's data. So that is, in fact, achieving the same thing. All right. Let's go back and let's time those two. All right, so I would do this. And then that was our timing for our for loop style. So in this case, we got 216 milliseconds, and that's doing the reassignment. And then let's time this vectorized operation. All right, so in this case, we're talking about milliseconds versus microseconds, right? So I think essentially 1 millisecond is 1,000 microseconds. So we've at least got roughly a 10x speed up. I'm just doing some quick math. No, it's more than 10x, right? So if we were going to represent this as microseconds, that would be 216,000 microseconds. So if we do a 249, yeah, much faster, right? So it's utilizing NumPy under the hood. It's doing all of those at one point. So whenever you can, you want to avoid looping over data frames, and these string accessor methods make it really easy to do this. All right, let's just look at another case real quick. Here's one that I will use a lot. So we've seen things, of course, you could do a dot lowercase, we could do a dot replace. Those are all, pretty standard things. But what if we wanted to create two new columns? Again, I'm hoping that, they're just using a first name, last name. But what if we wanted to create two new columns with the first name and the last name, right? All right, so let me grab the customer name column. All right, let me get my string accessor modes, do a dot tab. All right, we've got a string split method. All right, so I can say, well, I want you to split on white space, right? And notice that it changes that to a list, right? So you can actually, it looks like it's a list that's being stored. And notice right now, this is just a Pandas series, right? So we don't have a column label, we have index label. So if I want to grab this first entry, I can do a dot loc and say, give me back whatever has index label 0. All right, so that's giving me that back. And if I look at the type of this thing, it's a list, right? So when we did the string split, we can actually convert that into a list, and you can actually save that right into the data frame. So you can have a list right there in the data frame. All right, but then in our case, what we wanted to do is we wanted to create two new columns, first name, last name. Right, so we don't necessarily want to have a list stored in the customer column because that's messy. How do we search that with Pandas? It gets a little bit messy. All right, so in this split method, there is an option, and like in this case, my tab completion's not working, so I can't pull up the doc string, and it's because I'm doing this chained assignment. So what if I need to know the information about string.split? Well, you could always go to the documentation. So I could do pandas string split. All right, so here is pandas series string split. If I look in the documentation, it says, oh, well, I can give it a pattern, which in our code, we gave it a pattern of a single space. And you can give it other arguments like expand or end, the number of splits, right? You can limit that, right? So just split once. That might be exactly what we want to do in case they have a middle name. Just put the middle name and the last name all in a single column. So we'll use that. So I can say, I just want to have one split. By default, that's -1, so it splits as many times as it can. And then notice that has an expand. So if you expand, if you set that equal to true, it returns a data frame. Okay, expanding the dimensionality. So let's see what all of this looks like. All right, so let's do the string split. We saw we could say n equals 1, still returning a list. And if I forgot my documentation, of course I could keep it pulled up on another tab, but you can force JupyterLab to render it. So I'm just doing that string split, taking off the parentheses, and you can wrap that all in help. All right, so it will give you that documentation. All right, so there we go. There's that string split documentation. We can see we've got the pattern here. We can give it an in argument. We can give it an expand option. All right, so we've got our in argument, and then let's look at this expand. I'm gonna set that equal to true. So now we've got two columns. So hopefully this is going to be our first name, and this is going to be our last with potentially a middle name thrown in there, right? So we've got this. Now, what if we want to create new columns? right? So this is just returning things, right? This is doing nothing in our data. So if I look at, it's saying, oh, well, I've got a column 0 and 1. So it doesn't even really know what to name them, right? So, and if we look at our data, right, and in particular, let's look at our data.columns, right? We don't have those columns in there, nor do we want them in there. We don't want a column 0 and 1. That's not very informative at all. But what we can do is say, Pandas, you know what? I want to create 2 new columns, and we'll call this first one first name, and then we'll just call it last name. All right, so notice I'm kind of using the way that I normally access columns, but I'm passing in a list. So in this case, I'm saying, okay, well, create 2 new columns in this data frame, and I know this, methods that I've been calling right here returned a data frame with 2 columns. So I can run that. And now when we go to our columns, we've got 2 new columns, first name and last name. All right, so there they are, right? So that's a simple way that we can do this in a vectorized fashion, right? We don't want to write a for loop when we're dealing with pandas. Since it's NumPy under the hood and we get really significant speed ups with NumPy, we want to use that. We want to leverage that as much as possible, and we can do that with these vectorized operations. And a lot of times we're have to do a lot of work with strings, so that is an approach that we can use to do those string operations in a vectorized manner using that string accessor or that .str accessor. All right, so that shows you how you can access your string methods when you're working with data in Pandas.